Hey everyone, this is Miss Weaver, and this is the video for section 5.2, part 1. Okay, some of the key ideas that we're going to talk about in section 5.2 that I want to pull out from the interactive assignment that you've hopefully already looked at is the idea of the formulas that the book and the videos may talk about, and then also how we're going to be finding OR probability. So what does it mean when we're looking for the probability of A or B? And that's what we're going to talk about in this video. In the other two videos, we will talk about contingency tables and our third rule of probability. All right, so once again, I'm going to start off by reminding you guys that I'm going to attempting to use this easel lens, and there are definitely in section 5.2 and in section 5.3 lots of things that are really just existence level, and really I don't want us to use them at all, and those are mostly the formulas. So if you're looking at those formulas where you've got probability of A or B equals the probability of A plus the probability of B minus the probability of A and B, forget that if you can. I mean, you want to use it, you can use it. I'm going to try and show you a simpler way to go about the probability, because we're not wanting to dig into in-depth, deep probability calculations that might need those formulas. We're going to be looking at situations where we can see everything and we can pick out, well, that one counts and that one does and that one does and that one doesn't. And so I know which ones count for the event that I'm trying to find the probability of. That's all I need to know. Of course, then you'll have some supported, independent, and really kind of just one lifetime topic or idea in section 5.2. All right, so I basically have just one thing to say about the formulas, and that's basically just nope. I don't want you trying to focus on the formulas for these sections. I definitely don't want you memorizing them. There's a couple, like the complement rule, but that's really a rule more than a formula. I will let you know which ones you need to know, and I will hopefully be answering questions in a way that you see I'm not trying to use formulas. Now, we will definitely use formulas as we move on. In Chapter 3, we're going to have, the mean and things like that. Obviously, those formulas are important. That's a different story. But in Chapter 5, I want us to steer away from the formulas and think about how we can get the probability just by looking at the situation. Let's take a look at an example so you can see what I mean. All right, so just as a reminder from your guided notes, this was typed out already, so I went ahead and just put it up on the screen. I normally absolutely hate just reading PowerPoint, so if you're seeing this and you're thinking, oh no, she's just going to have videos reading through her PowerPoints. No, that is not my goal. I've had the headings at the top kind of just to keep me on track, make sure that I kind of flow through the material in a meaningful way, but I do not want to just sit here and read PowerPoints to you. You all could do that on your own time. But this is important. So our intuitive method for finding the probability of A or B. So let's take just a generic example. What's the probability of someone having brown hair or blue eyes? Now, normally, if we were in class, I would have everybody who has brown hair stand up. And I would count you, and we'd know how many you are. I'm going to have to make some stuff up for this one. And you had some Venn diagram stuff in your interactive assignment. So I'm going to use that idea. And so we're going to make our Venn diagram. And I don't know how many of you all actually have brown hair. I do know that there are, I guess I could go and look on the pictures on the Padlet page, but I'm not going to take the time to do that. So if this isn't right, I'm sorry. But let's say that out of the 23, I think, it's either 23 or 23 including me. So either way, let's say that out of 23 people, I won't say students in case I'm one of those. Let's say that, I don't know, 14 have brown hair. And that would be a kind of a self-identify thing if we were doing this in class, because I personally have very brown hair naturally, but I have very auburn hair selectively. So I like to identify as someone with red hair more than brown hair. But we have 14 people with brown hair. And then let's say that we have 7 people with blue eyes. Now, eyes are a little bit harder, but again, color contacts, I guess you can self-identify. If you want to say that you have blue eyes because you have blue contacts in, then you would have been able to stand up. But let's say that, then I say if you stood up both times, stand up again. And so maybe we have, 4 people who stood up both times. Well, if we let this little box over here, this circle, be our blue eyes, and we let, I guess I can't use B for both, can I? I better say BL and BR. And of course, this is hair and eyes, not eyes and eyes. Very, very, very rare occurrence when you see someone with a blue eye and a brown eye, or 2 different color eyes. It is possible, but very, very unlikely. So I'm going to, if I have 4 people who have brown hair and blue eyes, that means that there are 3 other people who have just blue eyes, but some other color of hair, or possibly no hair. If we had somebody that was bald or shaved their hair, then they would not have brown hair, but they could have blue eyes. So there are my 7 people that are representative of my blue-eyed people. And then we've got 14 total people with brown hair. Well, and I'm going to do this just for a moment. I'm going to just kind of cover this up, and I will put that back in just a second. I will delete that box. But so now if I just look at brown hair, well, I've got 4 people in that circle that is made up of brown-haired people. So I need 10 more. So there's 10 and then plus 4. So that's 14 total people in that circle that have brown hair. Now if I take that block that I've got away, there we go. So now we've got everybody. So I don't have 21. I don't want to just add these up and say that I have 21 people out of 23 people have brown hair or blue eyes. I want to count how many total people stood up. So if you stood up one time or both times, either one, then everyone would stand up, and we would have a total of 17 people, right? Because we've got 14 here, plus 3 more. So if we want to know what's the probability of someone having brown hair or blue eyes, that would be 17 out of 23. I wish I didn't have to make that up, but that's okay. So what did we do? We found the sum of the number of ways A can occur, 14, and the number of ways B can occur, it was 7, but making sure you do not count any outcomes more than once. So really just 3 more. Then we divide that sum by the total number of outcomes in the sample space. So what does this mean as far as our people? We've got 17 people in one of these 2 circles. So we've got people with blonde hair, red hair, green eyes, Pink hair, if it's still pink. I know one of the pictures had pink hair. Um, so we have some people who are not in one of these two circles. And in fact, we have 6. So somewhere out here inside this box, there are 6 more people who are not brown haired or blue eyed. And now we've got our entire class within the box.